Good morning, my name is Paco Gómez. I am the project coordinator of the De-RISC project, an initiative partially funded by the European Commission under their Horizon 2020 program. The project started in October 2019 and it is expected to be complete by September 2022. This is the contents of my talk. I will start presenting an overview of the project and of the entities involved in the technology development, and I will describe the technology developed so far. Finally, I will present some performance results and draw some conclusions. The project is carried out by 4 participants. Cobb and Geisler as experts in space-qualified hardware and rad-hard processors, fentISS as expert in space-qualified and mixed-criticality system software, the Barcelona Supercomputing Center providing their expertise in hardware support for high real-time multicore architectures, and finally Thales Research to benchmark and validate the technology developed with real aerospace use cases. From the user's perspective, the project addresses 3 major objectives: increase the low performance of current space-grade processor with a scalable multi-core architecture based on RISC-V, remove the obstacles created by expensive licenses, decrease in software support and export restriction of traditional space processors by providing a design based on open standards, free of export restrictions and with extensive support from a growing community. And finally, improve space software validation and qualification support by providing space-grade time and space isolation and mechanisms to decrease core interference in real-time applications. The core of the hardware technology has been developed by Geisler as a scalable NP-SoC. This NP-SoC is based on Noel-5, a powerful 64-bit RISC-V instruction set implementation which includes hardware mechanisms to support time and space isolation and the RISC-V H extensions for full virtualization. A parallel project executed by Geisler will provide a much more powerful ASIC implementation using the building blocks developed in the RISC. Note that Noel-5 model is already available as open source in the Geisler website. In addition, the Barcelona Supercomputing Center has developed a so-called safe statistical unit to help manage the core interference in critical real-time multi-core systems. This unit measures the core contention in the AMBA bus and the maximum latency per request time to help estimate the worst-case execution times of the applications. It also allows the developer to set up core contention quotas. The functionality of the safe statistical unit is currently extended to support contention beyond the AMBA bus in L2 to DRAM bus. The software technology is being developed by fentISS. They have ported their multicore hypervisor XNG to the fully virtualized version of the Noel platform developed by Geisler. Note that the RISC-V H extension is not completely frozen, thus some workarounds have been implemented to cope with missing features, in particular the interrupt management in HS mode. The GNU assembler version used does not support the H extension instructions, nor the access to the control and status register requiring to implement them as opcodes. Litos, the RX653 guest OS of fentISS, have been ported to the platform. Third-party guest OS as Artemis or Linux will also be supported. To make the products ready for the market, they are supported by a toolchain covering the customer's needs. First of all, the application software developer is provided with tools to ease observability of the execution and debugging process. Secondly, the system integrator is provided with tools to support the integration process and to develop feasible schedules for the different partitions, thus guaranteeing time isolation. The space ECSS Level B qualification for XNG is addressed within the project, following the B-model software development process defined in the standard and generating the required documentation and evidences. Finally, the technology described in the previous slides is being validated at several levels. First of all, some well-known benchmarks have been adapted to run over the platform, allowing comparisons of Noel 5 with other processors. Secondly, some kernels of interest to onboard processing have been adapted, giving information on the hypervisor overhead as compared to other solutions. Finally, full space applications and onboard systems are ported to the project platform to assess the overall performance of the solution as compared to other implementations. Note also that the safe statistical unit will be used to assess the isolation between partitions. Some remarks to conclude my presentation. The technology developed in this project makes RISC-V ready for onboard applications, both in payloads and in the satellite platforms. Time and space partition systems will reduce time to market and size, weight and power consumption, being a competitive advantage in particular for new space constellations. The De-RISC platform will allow the space industry to profit from the RISC-V ecosystem, which is developing worldwide. This is the end of my presentation. I am prepared now to take some questions from the audience.